And welcome back. As we continue looking at our planet, we of course last time had looked at some of the changes of our planet's evolution through forces that happen on the planet. But what about cosmic influences that might affect the evolution of Earth? So one of the things is very easy to ask. If we look at Earth and we look at some of its neighbors, such as the Moon, Mercury, and stuff like that, you might ask, where are all the craters on Earth? Because you look at, for example, Mercury and the Moon, they're heavily cratered. Well, it's impossible to think that Earth escaped being shook by interplanetary debris that has sparked things such as the Moon. One of the things that we have going in our favor, though, is that our atmosphere does provide us with some defense, so small pieces of cosmic debris burn up, but the layers of our air provide no shield against large impacts that form craters, and these craters are pretty common on the Moon. Earth, therefore, must have been impacted at some point in its history as heavily as the Moon. The biggest difference is that on Earth, these craters are destroyed by our active geology before they can accumulate. Remember, our plate tectonics is constantly recycling our crust. It's constantly renewing it, getting evidence of any past cratering events slowly erase. Now, we also, of course, have things like erosion forces that are present that can also, erase them on the surface. And it's only in the past few decades that geologists have succeeded in really identifying the erodive remnants of many of these impact craters. So let's start looking at a couple impact craters and really start examining what they mean in terms of our planet's history. So here we have an impact crater located in Algeria. It's a 4-kilometer wide crater. If you look at it, it's this kind of round feature right here in the center. That is our crater. This is a result of a meteor impact during the Cretaceous period, so back during the dinosaurs. Now, although this crater has experienced heavy erosion, again, using things such as wind, rain, etc., this image from the International Space Station shows the circular pattern resulting from that impact. Now, over the history of Earth, these impacts have had an important influence on the evolution of life. So let's talk about some more recent impacts, because you might think, oh, well, craters are things from long ago. We don't experience any more impacts. Well, that's actually not true. The collision of interplanetary debris with Earth is not a hypothetical idea. Obviously, we always might think, oh, here's a doomsday movie coming along, but one of the more well-studied historic collisions of Earth and a planetary body took place on June 30th, 1908, near the Tunguska River in Siberia. Now, in this desolate region, there was a remarkable explosion in the atmosphere about 8 kilometers above the surface. Now, because it was an explosion, it generated a shockwave that flattened more than 1,000 square kilometers of forest. Herds of reindeer and other animals were killed, and a man at a trading post 80 kilometers from that blast was thrown from his chair and knocked unconscious. The blast wave spread around the world as recorded by instruments designed to measure changes in atmospheric pressure. Now, this explosion was not something that was unrecorded. People who were obviously very interested, and we have a lot of good evidence of the aftermath of it. This photograph, taken 19 years after the blast, shows a part of the forest that was destroyed by the 5-megaton explosion, resulting when a stony projectile about the size of a small office building collided with our planet. Now, no crater was formed from this impact because the projectile was shattered by atmospheric pressure. That's why we had the explosion. Now, had it been made of a stronger material, such as iron, it probably would have impacted the surface. Now, let's look at this with another impact of something that's even more recent than Tunguska. Tens of thousands of people witnessed directly an explosion of a smaller, only 20 meters, projectile over Russia in the early morning winter in 2013. It exploded at a height of about 21 kilometers in a burst of light brighter than the sun, and the shockwave of the 0.5 megaton explosion broke tens of thousands of windows and sent hundreds of people to the hospital. Rock fragments were easily collected by people in the area after the blast because they landed on fresh snow. Now, of course, these are much more recent ones, and they're pretty small, but Earth, of course, has suffered from larger impacts throughout time. So if we look at some of our more ancient impacts, one of the things we can look at, for example, is the best-known recent crater on Earth that was formed about 50,000 years ago in Arizona. This projectile was a lump of iron that was probably about 40 meters in diameter. Now referred to as Meteor Crater and a major tourist attraction on the way to the Grand Canyon, the crater is about a mile across. Meteor crater is one of the few impact features on Earth that remains relatively intact. Now, of course, we always dread this, and that Hollywood loves to use this for, doomsday materials. But of course, impacts can lead to mass extinction events. Much larger and rare impacts, however, can disturb our ecological balance of the entire planet and thus influence the course of evolution. The best documented large impact took place about 65 million years ago at the end of what we call a Cretaceous period of geological history. This time in the history of life on Earth was marked by a mass extinction, in which more than half of the species on our planet actually died out. This is the thing that, we associate with the end of the dinosaurs. And where did this happen? Well, it happened in the Chicxulub crater, right off the Yucatan Peninsula in Mexico. This crater is about 200 kilometers across, and it would eventually lead to the extinction of the dinosaurs. Its sediment layer is rich in the rare metal iridium and other elements that are relatively abundant in asteroids and comets, but exceedingly rare in Earth's crust. The impact lifted about 100 trillion tons of dust into the air, blocking sunlight completely. Additionally, large-scale fires and acidic rain would have been triggered by this impact. Now, these impacts, of course, can have a huge influence on the evolution of life. Impacts by comets and asteroids represent the only mechanisms that we know of that can cause truly global catastrophes and seriously influence the evolution of life all over the planet. As we just talked about with the dinosaurs, all that is, the asteroid may not have killed everybody right away, but the things like large-scale fires and the acidic rain probably did in a lot of species. Early in its history, Earth was subjected to even larger impacts from the leftover debris of planetary formation. And some of these impacts were probably violent enough to strip the planet of most of its atmosphere or to boil away its oceans. Such events could have sterilized the planet, destroying any life that had actually begun at that point. So, for all we know, life may have been formed and even wiped out several times before our own microbial ancestors formed and led to the modern form of life as we know it. Now, this, of course, leads to an interesting question. Are there impacts in the future? And we saw, of course, recently that there are two impact examples that we saw that were relatively recent. Humanity could suffer the same fate as the dinosaurs, or lose a city to the much more frequent impacts like the one over Dagunsa. These things are still possible. So, beginning in the 1990s, a few astronomers began to analyze the cosmic impact hazard and to persuade the government to support a search for potentially hazardous asteroids. Several small but sophisticated wide-field telescopes are now used for this search. Already we know there are currently no asteroids on a collision course with Earth that are as big, which would be 10 to 15 kilometers, as the one that killed the dinosaurs.